taking notes of this.
Any questions about the extra credit? Time's running out. I'm not sure when you're planning on finishing up, but what you might want to do is just go out to the link for the Writing Center and set up a time with them, even if it's in advance, right? So let's say you don't get to review your paper until this weekend. You might get to school Monday and there's no spots left for tutors. If you don't get to talk to someone at the Writing Center Monday, you cannot earn the extra credit. So if you think that you'll have your paper reviewed and edited by Friday, maybe set up an appointment for Friday. If you think that you won't be able to get to it until the weekend, then I would set up an appointment in advance for Monday, just so that when you get to school Monday, you have the ability to talk to someone at the Writing Center and then earn your extra credit. All right, I want you to get the extra credit. That's why I have the extra credit assignment, but I can't extend it. So if you don't get it done by Monday at the deadline, you won't be able to get the extra credit. All right, so as far as I know, they still have appointments for Friday, they still have appointments for Monday, but I don't know how quickly those will go, because there's like 80 students that are going for the extra credit, plus they just have their regular people coming in to get help. So you'll be up against a lot of people if you wait until the last minute. All right, any questions? All right. So what we want to do today, we want to finish up with algorithms and then hopefully get into multimedia. Last time we were together, you reminded me that we did look at this chart, this table of comparison sorts. Right? We haven't really gotten into any of the sorts and how they work or what the algorithms are, but we will talk about that. Just as a reminder, it is showing the big O notation, the classification, log of n. Some of these are n squared. We just had an n, right, which is our linear algorithm. Let's see, I'm looking to see if there's any exponential ones listed here. I don't see any. But we do have a good collection here. Some of them are great on time, some are great on memory, some are horrible on time, but good on memory. Right? Some of them are good on time, but bad with memory. So today I want to start off by looking at two algorithms for sorting. The first one is going to be a quick sort. And if we look at this table, this is showing us that a quick sort is really, it has a great best case scenario, it has a great average case scenario, but their worst case scenario for a quick sort is pretty bad, it's n squared. Right? So n would be the total number of items that are being sorted. The worst case scenario is that you take the total number of items and you square it, that's the worst case scenario. So if you had 5 numbers that you needed to sort, the worst case scenario is 25. If that goes up to 10, well now it's 100. You have 100 now, right? It's not good. As your number of items start to grow, it can quickly get out of hand. All right. If you look at the memory, that's just average. It's not bad. It's not good. It's average. All right. So there's a video out here in YouTube land, and this is a Hungarian dance troupe. And one of the things that they do is they dance out algorithms. And here they're going to dance out a quick sort. So we have the numbers 0 through 9. They're all mixed up. All right, they need to get sorted out. And what I want you to do is see if you can pick up what the algorithm is. Now when it starts, you're going to see the number 3 come out and the number 6 come out. Let's watch it for a little bit and then see if we can pick up what's going on. All right, but what they're doing is they're actually playing out a quick sort just like it was happening inside your computer. Although inside our computer we don't have these fancy men.
No.
All right, so let's go. going to speed it out. Speed it up.
Okay, there those two are.
Right, so you're noticing that the number 3 is out there,
Mm-hmm.
but all the other numbers are coming out
Mm-hmm.
and going back in. So right now,
And they
where the
switch
number
places.
3 and the number 2 switch places.
And then here comes number 1.
The number 3 and the number 8
They swap
switch
places.
Number 3 and number 7, they don't switch places.
Hmm.
All right, then the number 3 turns his back on everyone, and then they spread out from the number 3, so that there's 2 partitions there now. So what do you think the algorithm is? What are we looking at? The number 3 came out,
Mm-hmm.
and started dancing with all these numbers. For the most part, the numbers were dancing with the number 3, but then going back in their place. But every once in a while, they would switch locations.
The 3's coming out and checking with every number to see if the number that pops out is bigger or smaller. If it's smaller, it goes in front. If it's bigger, it goes behind. And then
Mm-hmm.
once it does that for all 10 numbers, then 3 is done. It can go back in. So then it gives just the numbers below 3 and just the numbers above 3 on either side. So that they can do it. They can repeat in their own groups.
That's exactly what happened,
In their
right?
own
The number
groups.
3 came out. It compared itself to the number 6, the number 9, the number 4, the number 5. The number 3 was less than all those others. So when they were dancing,